In the Mercedes-Benz Model Series 221, the onboard power supply was changed in 2008. From now on, a single onboard battery is installed, i.e. the onboard battery is no longer positioned in the trunk, but has taken the place of the starter battery in the engine compartment. Now with the single onboard battery, we have removed the starter battery and instead installed the onboard battery in the same position here in front of the engine compartment. This has the battery sensor on the ground terminal. The battery sensor is connected by a LIN bus cable to the SAM driver, which is under the engine control device. In petrol-driven cars, the SAM driver is installed in the control device box. With diesels, it is under the engine control device. In the SAM, there is the onboard power management software, which controls the onboard power functions. You'll see here on the left the modified engine compartment with the onboard battery. On the right, you see how the engine compartment used to look before the year 2008 change. Here, the starter battery is installed in place of the onboard battery. Also belonging to the new single battery of the S-Class is the onboard management software in the SAM, the closed-circuit current switch in the fuse box, and the intelligent battery sensor. The battery sensor, together with the SAM driver, take over the onboard power management. That means we can initiate measures in critical situations which stabilize the onboard power again. These are the idle speed control, the power consumer device reduction, the temperature-controlled charging regulation, and the closed-circuit current optimization by means of the closed-circuit current switch and the quick battery charge unit. Along the lines of the 204, the battery sensor can be selected by using star diagnosis, and the closed current circuit can be checked. What's new is the data records of the battery sensor are no longer transferred upon switching the ignition on or off. The original data record is transferred only after a distance of 100 meters. There is, however, an exception. The entries which are generated due to increased closed-circuit current can also be put on a new record with the same mileage. Start the closed-circuit current check through the SAM driver and select Onboard Power. Then the menu Actual Value. Then the current data of the battery sensor. Next, Battery Power. And lastly, click the menu Performance of the closed-circuit current. Here you can see the last data records and read the closed-circuit current. If you select a data record, you can now see at exactly what mileage the record was stored. Now again back to the battery. For the charging of the new single onboard battery, pay attention to the following. On account of the high power requirement of the Model 221, only battery chargers with at least 30 ampere charging current may be used. The battery may not be charged by connecting directly to the negative terminal, because otherwise the charging current will not flow through the intelligent battery sensor, and therefore taken as the old battery level. It goes like this. Attach the plus clamp to the positive terminal of the battery or the long connection bolt in the fuse box. The minus clamp is connected to the ground bolt, which is situated on the front wheel arch. Now the charging current flows through the intelligent battery sensor and is monitored. There is a specific feature with jump starting. The plus terminal is not suitable for the jump start because the terminal does not have enough contact pressure. Under certain circumstances, a drop in voltage can result from a jump start. Therefore, connect the clamp directly to the positive terminal of the battery. Attach the negative clamp as before to the ground bolt. When the battery is loaded properly, it supplies all electric consumers with power and makes sure that the engine starts. However, with a certain task, the newly developed single onboard battery gets support from the emergency battery. This is installed behind the rotary light switch. Should the onboard battery run flat, then the emergency battery makes the necessary energy available to activate the parking lock of the Another technical innovation is installed in the fuse box. It's in the footwell of the passenger side. The fuse box forms the interchange of the energy distribution in the interior of the vehicle. The closed-circuit current switch is also integrated in the fuse box. When required, it switches off the terminal 30G. This happens in 3 cases. First, if the vehicle is off for longer than 6 hours. Secondly, if the main voltage falls under 11.8 volts. And thirdly, if the closed current becomes greater than 75 milliamperes after approximately 75 minutes. It is thereby guaranteed that consumer devices with an increased closed-circuit current will be switched off at terminal 30G and the battery will not run down. The charge or discharge current of the battery can now be displayed at any time through the menu Vehicle Data in the instrument cluster. This way it's easy to keep an eye on the battery level. The menu functions along the lines of the Model 221 before the 2008 change. When you enter the menu Vehicle Data, press the OK key. Now you can read whether the battery is in the charging or the discharging state. If, for instance, the ignition is on, the battery will discharge and a minus appears. If you start the engine and the generator charges the battery is in the charging state. We now devote ourselves to the new idle speed control. It counteracts possible discharging in neutral. This is, for example, the case if you need more power in neutral than can be delivered by the generator. Then the idle speed is not lowered to the base idle speed, but depending on power is automatically set to 650 or 750 RPM until the onboard load decreases again. And lastly, some interesting facts about the new quick charge function of the battery. With the quick charge function, the output voltage of the generator is raised to 15 volts after every engine start, until the battery charging current falls under 30 amperes. The quick charge function therefore helps short-distance drivers, so the danger of a flat battery is clearly reduced.